Good morning, everybody. Thank you for joining this webinar today. So apologies for starting a bit later. We're just waiting for a few more people to join. So my name is Justin Olivier. I want to be the host today for the webinar. And again, thanks for joining. This is our second one we've done in South Africa over this year. So I'm an enterprise account manager at HashiCorp. I look after the Middle East, South Africa, and the rest of Africa. And today, we're very excited to have the opportunity to discuss infrastructure automation with everybody, and ways of reducing costs in cloud consumption. So today, joining me is going to be one of our regional solutions engineers, whose name is Lance Haig. And Lance is going to explain to us how to kind of control the costs and minimize cloud waste using Terraform. So after Lance has run through that, we're going to hear from Jared Nordia. So Jared's one of the senior cloud architects at Synthesis Technologies. They're one of our main partners here in South Africa. And after we've heard from Jared, then we're going to hear from Siva Sadhu, who's a senior partner solutions architect at AWS. And Siva's going to run through some of the experiences that he's had with regards to implementing Terraform and how some of his customers are using that. And then post that, we'll be running through a series of questions. So please feel free to ask any questions that you might have. Just a bit of sort of housekeeping and mentions here that, the webinar is going to be recorded. After we've processed the recording, we'll share that usually probably in about 2 or 3 working days to everybody. So as we go, please feel free to, type any questions in the question box, and we'll address those in the Q&A section. So with that, let's kick things off. I'm going to hand over to Lance. Thanks, Lance.
Thank you very much, Justin, for the introduction. I am just sorting out my slide deck. Sorry. Something's just gone tickety funny right there now. So welcome everybody. Thank you again, Shiva and Jared, for joining us today. We really appreciate it. Can you see my slide deck, my slides, the HashiCorp sign?
No, Lance, we're seeing the Slack channel. So
okay, then that's not good, is it? Let me quickly do that. What a way to start. There we go. That's better. There we go. That's good. Well, welcome everybody. My talk today is going to be around how to control costs and minimize cloud waste with Terraform. This is going to be about more around the process and what one needs to think about when doing cost control in clouds, and how Terraform with its feature set can assist you in doing and managing these costs, because obviously there's a bunch of challenges that one faces when managing costs. So again, a little bit about myself. I'm a regional manager for solutions engineering here. I'm actually based out of Germany at the moment, but originally from South Africa, as I'm sure you can tell. And you can find me on most platforms under Al Haig if you're interested. Just to make sure that we level set a little bit about what HashiCorp does and is. As you can see here, we're the leading cloud infrastructure automation company. I think it goes without saying that a lot of our tools, if you can see all 8 of them down the bottom there, are used and consumed by everybody who should be doing clouds, are using them in some way, shape, or form, whether it's Packer, whether it's Terraform, which is what we're talking about today, but Console and Vault and Nomad and Waypoint and Boundary. There's a bunch of tooling. So just we cover all the layers of your infrastructure, whether it's infrastructure, networking, security, and application. And I think well, the nice thing about our tools, which I really like, is that we've got open source versions of all of these. So you can play around, get them working as much as you can. And when you need the enterprise feature set, come talk to Justin. He knows how to get you sorted and arranged to see what the features are in the enterprise. And just to reiterate, while we've all moved migrating to the cloud, I mean, just the whole current scenario we're in for the last couple of years has been pushing a lot of companies to go into the cloud scenario, because it is easier to manage this infrastructure there when you've got people who have to be working from home because of the current situation. And but this brings in kind of new control points for us at each layer of this that we need to identify, manage, and use tooling to help us control how these these layers are utilized. For example, the infrastructure, which we're talking today, that's where you would use infrastructure as code. And then your security scenario, you want to be using identity, because if you attended my last one here in South Africa, the zero trust talk, identity is key for your zero trust environments, and you need to make sure that you have that control point as identity. And then obviously with your networking, because things are dynamic, you want to use a service registry to make sure that your applications can talk to each other without having to open up firewalls and things like that. And obviously you want to do containers and orchestration, because there's a lot of things that you want to be able to run. And this is where you need to manage those containers or batch jobs or whatever, using the application tooling, the application deployment orchestration tooling. So with that said, we have the cloud market at the moment. And I know a lot of you probably have seen some of these data. So please bear with me while I'm doing this. But this is where we kind of started at the moment. The cloud market growth, the annual spend that people do, the amount of money that people are spending on the infrastructure as a service in the public cloud is $64 billion. That's a huge amount of money. That's surprisingly large. And one of the things that we as people in this call are spending on is not only when you're using your own tooling, for example, but when you're using Netflix or one of the other providers of solutions out of there, they're also using the cloud. So you're helping them spend, get up to the 64 billion. But the cloud growth over the last while from 2019 has been a 41% increase. So, my previous statement about the improvement of everybody moving to the cloud, this is validated by the numbers. And this is a Gartner link here at the bottom. When you get the slides, you can go and read on there where we got this information from. It's really a huge growth of 41%. And if you look at how it goes over the last couple of years, so 2018, we saw between 2018 and 2019, we saw an average of 48% growth with regards to how much people are using the cloud environments. And then when you're looking at the 2019 to 2020 growth, we're looking at a 41% growth just in that time frame. So it's quite surprising is to see how big some of these numbers are and how much people are spending on each of these cloud environments. So for me, that's really an indicator that there's a lot going on, and also a lot of multi-cloud going on, because every cloud provider is growing, and they're growing at a rate that's quite large. So this multi-cloud kind of growth pattern, that for me is the crux of how things are going in the future. And we now have the scenario where obviously when you start growing and deploying into the cloud, you're going to have some kind of cloud waste, because things happen, people make mistakes. And so if we take our original $64 billion spend on the infrastructure as a cloud service, of that number, 17.6%, listen to me, $17.6 billion is actually wasted on cloud waste. Sorry, that was a so the cloud waste itself is huge when you think about it. That's a lot of money. I mean, that's huge. And when you think about it, that's 20 to 35% of all cloud expenditure is cloud waste. And how does this manifest itself? I mean, but what we want to do is we want to see it. Look, this value, the 17.6 value. What is it? It's actually the revenue of the 183rd largest Fortune 500 company. So a whole company's revenue is just thrown away every year in cloud waste. And that for me is quite an eye-opening value, right? When you think about it, that this whole company's money could just be dumped because of the waste that's happening in the cloud. And how's this split up? Well, we've got mostly idle and over-provisioned resources have the biggest impact on this $17.6 billion. And if you look at it's about $5 million wasted every day this year. That is unbelievable. $5 million. It's a lot. And it could have been, we could have utilized this for other things like R&D, renovation, or just keeping the cost down, obviously, because doing business in the current status of where we are is very, very challenging. And if you could have just made those savings, this will definitely help the bottom line for your companies. And then what we want to figure out is, how does this waste happen? What are the key factors that we've seen in the industry of how this waste happens? And what it is, it starts out, one of the factors is reduced productivity. So what it is that people who, developers, the people utilizing infrastructure or utilizing the cloud, they have no way to reuse or collaborate or to make themselves more efficient when they are deploying items in the cloud. So everybody reinvents the wheel. So they spend a lot of time redeveloping, creating their own infrastructure. And then when it comes to a DR or a repeated fashion, then they have to go through this whole thing again. And this is where the productivity options of the wastage come into play. And then we've got another part is where we've got some risk. So we've got a problem, or when you have a lot of the cloud deployments happening, you have a list, you need to have governance. And this governance and oversight means that you can guide the teams when they're deploying how to and when to deploy stuff and what they're allowed to deploy. In other words, what instance sizes, those type of things, because people, developers, as probably everybody knows, will try and deploy. They will believe in their head that their application needs 200 gigabytes of RAM when in actual fact it needs 4 gigabytes of RAM. And these are the ways that you want to be able to sort it out. And also there's a lack of standardization. And anybody, myself included, who's done some system administration for a large number of machines at one time, you know that standardizing deployment, standardizing management reduces your time to failure and reduces the downtime in general of the business. And when you don't have a standardized way to do this in the cloud, it brings its own challenges and also brings a longer time frame for recoveries. And there's also a lot of potential for failure, human failure, making mistakes, opening up ports that shouldn't be open, opening up buckets to the internet and so on. And then obviously there's the unnecessary cost, which we alluded to in the beginning of this, is that idle resources. Somebody deploys a test cluster on day 1 and day 3. They've decided that they've moved on to a new team and no one knows what this cluster is doing. And so it just sits there and there's 20 machines sitting there doing nothing, but no one knows if they can turn it off or not, because there might be an application that relies on it. And without that kind of tracking and monitoring, no one knows what this machine is doing, and it's just sitting there, or these clusters doing, and they're just using money and generating money. And then obviously orphaned resources, where people don't delete everything that they've deployed and they've leave something around like IP addresses or load balancers. And these things just run up costs without actually being utilized. So having said where that is coming from, what we're doing in the cloud waste environment, or how we're wasting money, where are we going to go? How are we going to solve this, right? And if anybody's has seen any of my talks before, they know that I kind of trying to make sure that we have 3 or 4 points or layers or key items that we need to remember from our perspective. And obviously, there are a huge amount of opportunities or ways to do this, but we're talking about Terraform at the moment. So my 3 words for this talk would be automate, standardize, and govern. And we're going to go into depth of each one of these. But if you remember that, it could also be ASG, auto scaling group, but automate, standardize, and govern is one of the ones that we want to do, right? So we're going to start out with automate. And how are we going to do this? So what you want to do to control these costs is to create or use infrastructure as code. And by using this automated way of deploying infrastructure, you would be able to apply policy to these deployments, have your teams that are specialists in Terraform to create these tooling for you, to create this automated workflow so that you eventually start automating and standardizing your environments and deployments. So Terraform has a huge selection of providers that allow you to create or utilize many of the things that you're used to doing manually automatically using an API. So that what that means is it reduces your time to market. It reduces the deployment file. So that also then starts creating or reducing your costs, which improves your performance from a cost perspective. And what does infrastructure as code kind of give us in this respect? It's giving us agility. So once you start creating the standardized deployment methodologies, your teams can reutilize those methodologies and deploy code faster, quicker. So if somebody wants to get an application that's not been deployed yet into the front of your customers really quickly because it's you forgot to do something for the Black Week, you will then go in and you can deploy this, and in 15 minutes, this application can be up and running because you've used automated standardized deployments using infrastructure as code. What it'll also do, it'll reduce your risks because it'll minimize the manual work, the error-prone work that people, because as we all are humans, we make mistakes. You make a typo, you make a comma in the wrong place, and something will then happen to your environment. And this is where this will reduce the risk because it's standardized. And obviously by standardizing on these deployment methodologies, you start reducing costs because things happen faster. You have standardized sizes and instance configurations, and these things will then reduce the wasteful expenditure that you have within your infrastructure. And then obviously using version control systems, you want to make sure that your version control systems are utilized so that you can use the DevOps or the developer kind of workflow to deploy infrastructure. So you have a record, a system of record of your deployments, and you can use your CI/CD tooling that you already have inside your environment to produce these deployments, which then obviously improves the deployment methodologies, because many of the manual checks that used to be taken in the past can now be done by your CI/CD system. And this allows you then to reduce those times and reduce the people hours needed to process these requests for infrastructure. And obviously, if you match your workspaces in Terraform Cloud and Enterprise to a version controlled repository, this will then allow you to have less people in between when the developer wants to produce something, put something in the cloud, and when it actually arrives in the cloud. And then obviously with most of these things, I'm not going to go through each of these topics, but it increases your agility and reduces your risk. When you get the slides, you can read what's in there in the situation. So next we're going to standardize. So standardizing, how one does that with Terraform, you create modules. Those modules are utilized again and again by people to do the same thing. So you have a producer, which is your Terraform specialist team. It doesn't need to be a large team, but they will be the ones who understand the clouds, who understand the Terraform technology, and create modules that allow you to produce these standardized workflows, which are modules that that developers can reuse, which we spoke about earlier about reinventing the wheel. We don't want to do that. So this is how we stop reinventing the wheels. And then this also, again, increases your agility because it's faster. You deploy full infrastructure with one click of a button. It reduces the risk because it's standardized. Again, remember, standardization is really key here. And then it'll reduce the cost because you can limit the amount of, the types of deployments that people have, the types of machines, and so on. And then from governance and policy, this works out really well, because in your workspaces, you can apply all kinds of rollbacks, access control. You can create infrastructure where or environments where developers have the ability to deploy and maintain and see what's going on within their workspace, but they cannot, for example, change the policy as code environments or the VCS integration. And these fine-grained controls allow you to have that reduce the risk of errors by people making mistakes, but also improve the performance and the speed of the deployments into the cloud. And these version control kind of workflows, they are very, very important because you want to be able to have eyes on everything. And by having eyes on everything, you'll be able to see when there is a chance for an expenditure overflow, because you would have warnings from the Terraform environment to say, this is going over. It might be strange that I'm mentioning the Terraform state here, but for me, this is really critical, because you'd be able to see at any which stage during your process what your state file looked at, what was out there in the environment at a specific state. So by utilizing the Terraform state, you would be able to, as a management team, be able to see, okay, fine, on the 14th of December, we had a size cluster this side, and then on this date, it was created, doubled up in size by this size, and we need to understand why, because it doubled the costs. And you can go and see what changed in between those two states, And that's really important for managing the governance of what you're doing inside the environment. Again, we're talking about modules, about governance, because what you want to do is the modules, you get your team to create them, your Terraform specialists. What you then get is you get your security and your network teams to maintain it and kind of give them once over and give them the rubber stamp saying this is a standardized deployment methodology, a standardized infrastructure deployment that we want. And that way we can make sure that these the developers have the correct deployments, which means that you can standardize and reduce the costs of your sizes of networking and so on. And then obviously the great thing about Terraform Cloud and Terraform Enterprise is that we have this module registry, whether it's private or public module registry. And you've got a private module registry where you can create you can take the AWS VPC module if you want, bring it into your private module registry and make a couple of tweaks to it so that would more fit with what your company needs within that private, within that Amazon VPC, and then you can call it your company one. And then you can utilize things like Sentinel, which is the policy as code tool, to restrict that people can only use the private module registry and not have access to the public module registry, which again improves your security footprint and reduces the risk of mistakes from bringing in a verified module into your registry or into your deployments. And that way will reduce the costs of what you're using, because you're basically managing how things are deployed and when things are deployed. And then a really key kind of factor within this scenario as well is the cost estimation feature inside Terraform Enterprise or Terraform Cloud. What a lot of the customers use this for is that they use it to flag the items that we know the cost of. For example, your ELBs or your IP addresses or instances and so on, so that you can set a limit saying, if the value of this initial cost goes over $500 a month, we want to make sure that we flag this and someone has to approve it. So the advisory failed, for example, or you have different methodologies to restrict that these things get deployed. You can stop them deploying if it gets above, say 1,000, for example, but at 500, they can get approval. And this way, this will immediately, when people see the cost of what their deployment's gonna cost, they're gonna go, okay, this is a bit too expensive for my budget. Maybe I need to look at why mine is so expensive. What is the most costly thing? And in this specific case, it's the load balancer, which probably is not something that we can change, but at least you know where that money will be going. So I think that for me is really, really powerful. And then the key, capturing everything here in this last slide, or second last slide, sorry. How do you want to save or reduce these costs? You want to increase your productivity. So in other words, not let people reinvent the wheel. So using VCS integration so that people can do a fork of a module or a deployment, create that exact same fork, use the exact same fork, but just change the variables in their own workspace, and then they can have that deployment. So what would have taken hours or days or weeks, as some of our customers have seen in the past, reduces down to minutes, because the developer goes in, makes a fork, adds that to the repository or to the workspace, changes the variables, and they can deploy instantly. And that makes things much easier. Using CI/CD makes it even better, because when changes get made, they can go through your normal CI/CD pipeline, which means they can pick up those mistakes that people might have made, because people will still make mistakes, but at least you can pick it up before they get into production, which then reduces your environment. So this will be really your possibility to have errors. And then collaborating. So what we always suggest is that customers create an internal kind of open source mentality where all modules and all Terraform code is shared internally in an open source way, so that people can make pull requests, updates, or request changes, so that you are constantly evolving your deployments to fit what the company needs, but also to improve what their developer experience is to have this go through the door. And then when we look at reducing the risk, obviously, as I mentioned before, standardizing definitely reduces risk. I myself had an experience there where developers had root access to the systems, and we had constant failures of the machines over the systems. And then we standardized, where we removed a lot of the access for the developers. We also changed the way the deployment works. We standardized, and we saw a 60% drop in our deployment, at least in our downtime, just by standardizing on the deployment methodology and allowing developers to still do what they needed to do, but in a more standardized, safeguarded manner. And then we utilize policy as code, because as I said before, you want to make sure that your policies check that the systems aren't too big, they're not over provisioned, or they are not using the correct sizes of instances, or there are 5 IP addresses when they only need 1. These are the kind of things that you want to check to make sure. And then obviously you want to make sure that you have the audit logging capability, because later on you're going to come back and go, okay, we spent, as I said before, $600 extra this month. What went on? You can go back to the audit logging and see, okay, fine, someone deployed a huge cluster for 2 hours that had a $2,000 an hour machine running in it, and that's why we had so much of an extra cost. And then we want to reduce the cost as well. So the way is to eliminate these unnecessary costs. And if you use the 2 previous columns to manage that, if we use the information in the 2 previous columns, we can we will end up having these reduced costs, because you will catch those edge cases, you will catch those environments or times when people are overspending and creating these idle resources. And also with the idle resources part, if something is not deployed by Terraform, it shouldn't be in the cloud, or it shouldn't be deployed. And if it is deployed, there is a good candidacy for that to be destroyed. And if that's your policy, and the way to do it is to gatekeep everybody through Terraform, because that allows you to know exactly what was deployed where. Obviously, I mentioned before, cost estimation, very, very powerful tool to highlight what the potential cost is for their environments. And they want to make sure that you have these front and center when people are deploying, and it makes it very easy for them to see what they're going to be costing. And then best practices. This is, I think, one of my biggest requests or suggestions to teams is create best practices for your systems, create best practices for your company, create best practices according to security. Then what you want to do is you want to make sure that this is enforced by your Terraform code, so that when your deployments are going out there, the risk and your security footprint and the risk of cost exposure are as reduced as little as possible, because their people are using the modules that you are creating for the whole company. And I think that's important. And then going back to my 3 kind of key words: automate everything, standardize everything, and govern everything. And that way you will definitely reduce your costs in the cloud expenditure and on-premise. And that was super fast, because it's a 30-minute talk in a 25 minutes. So if there's any questions, please put them in the channel, the chat, so we can have a discussion in the panel later. Thank you very much. And that's my...
Great stuff. Thank you so much, Lance. Some eye-watering numbers there. Obviously, if you convert that into rands, even more so. So thanks so much for that. Guys, just a quick reminder, if there's any questions, please post them in the Q&A box. I'm going to hand over to Jared from Synthesis, and Jared's going to be running through a presentation as well. So Jared, over to you. Thanks, guys.
Thanks, Justin and Lance. Hello, everyone. Welcome to this talk today. So I'm going to be talking about, again, how we can save costs on Terraform. It follows nicely on what Lance has presented. So just a quick introduction about myself. My name is Jared Nordia. I'm a senior cloud architect. I specialize in security and enterprise cloud architecture. I've been using Terraform since version 0.6, so that's roughly 5 years or so. And I started using AWS in 2013. I work for a company called Synthesis. We offer specialized software development and cloud consulting to our clients in the financial services and retail sectors. We're an AWS advanced consulting partner, and we recently celebrated over 200 AWS certifications in the company, which is something we're actually really proud about. We're also a HashiCorp partner, where we help our customers use and adopt HashiCorp products, and that's what I'll be talking about in my talk today, with some use cases on how you can actually save money in a fairly practical way. So if we look at why people want to go to cloud, typically it's for cost reduction, agility, innovation, efficiency, and faster time to market. However, one of the things that we often see is that many organizations only see the end goal of being in cloud and utilizing DevOps techniques, but they don't think about the journey that they need to take their organization through. And one of the key things to really understand is that cloud is different. The operating model in cloud is very different from on-premise environments. Application teams have more freedom and responsibility in cloud, and potential misconfigurations can lead to very serious security issues. Many of you would be very aware of the the barrage of news reports of misconfigured infrastructure and the data breaches that have occurred as a result of that. And one of the things that we can do to really combat this is that standardization that Lance was actually talking about. So the way that we would do this is through componentization and using Terraform modules. So we can use Terraform modules to create and describe common architecture patterns and use cases with approved configurations. And these modules can be approved by the organization and then be implemented subsequently. If we look at an example, let's say we have an S3 bucket, which must not be publicly accessible. We want to restrict who can read and write the data, that all data must be encrypted and all data must be owned by the bucket owner, and that bucket must adhere to a certain naming and tagging policy. This is something we can actually do in Terraform, create the module, and then share that out so that everybody can use that module. And when they use that module, they know that the infrastructure that they are creating will be secure. And we can do this for any and all of the services that AWS provides. So, EC2, RDS, etc. And what we can then do is allow developers to use these services in a secure way so that developers don't need to be an expert in each service in order to use it in a secure manner. And then if you really start to mature, what you start to do is you take all of these modules and you start forming solutions around using these modules, which is really the way that you need to grow when inside of AWS or any other cloud platform that you may be using. So if we look at the target operating model, this is quite different from on-premise environments where you have an application team that only does engineering. But when we start moving into cloud, what we start to see is that application teams, they need to do engineering and the operations of their applications, where you might have a cloud team that looks after the cloud platform. But if you really want to grow with your cloud adoption in a successful way, what you really need to enable is the application teams to actually take control of some of the elements of the platform, and that really sets you up for success. And the way that you can do this is obviously by adopting infrastructure as code and by using these modules. So as Lance alluded to earlier, you could have a central team typically that will create a bunch of these modules that would enable the application team. But the key thing to success here is to allow the application teams not only to consume these modules, but also to create new modules that other teams can use. And by doing this, you enable scaled learning in the organization so that everybody can benefit from everybody else's work. So this is often done in code. So you might have, let's say, a JavaScript library that that does input validation, for example. So instead of each application team in the organization doing that, you can share that in a private repository. And you should really do this, take that same mindset and apply it to infrastructure. And when you do that, you'll actually be amazed at the innovation that can occur as teams build on work that other teams have done. So why does this matter? So when application teams start out in cloud, they are very likely to make costly mistakes when provisioning infrastructure, such as the example above. This is actually a real world example from a client of ours, where a developer got permission to play with an AI tool, spun up a very large instance, and forgot to terminate the instance once they were done. At the end of the month, they were sit with a $22,000 bill. Luckily, this was a large organization, so they were good with it. But if you were a smaller organization, this could have been quite a financial burden for this kind of mistake. So by using Terraform modules, a lot of common misconfigurations, such as security and incorrectly sized instances, can easily be avoided. Terraform Sentinel can also be used to enforce security guardrails and can be used to limit what types of instances can be spun up. Next, when we look at repeatable infrastructure, that's one of the other benefits of using Terraform. So you can easily move workloads from dev, QA, and production in a repeatable way, and this allows infrastructure to be easily created, replicated, and destroyed when necessary. One of the other benefits, though, of using infrastructure as code with a tool like Terraform is that if you need to create temporary infrastructure, whether that's for a high traffic event, for incident response, or for an unusual event, for example, like let's say you get a subpoena for a legal hold for a specific type of data, typically you would need to spin up additional infrastructure for that, and having that coded before the time, and then when the incident occurs, you can then actually spin it up, is very, very powerful and can be a very big cost saver in the organization. We really saw this with the Cape Town region. So last year, after waiting many, many years for the AWS region to come to South Africa, it was eventually, officially launched. And then we immediately started diving into trying to use it. And we had some hurt feelings because things didn't work out initially. And luckily this, was resolved in a day or two. One of the evangelists from AWS created a pull request on the Terraform repository, and that basically sorted everything out. And we were then quite excited to actually then play with the new region, within hours after it being officially available. And what we actually saw is a lot of our customers that were already using Terraform were easily able to move their resources from Ireland, which is the region that most South African companies used before the local region was available. Because they had all of that infrastructure in Terraform already, they could just change the targeted region and easily spin up that infrastructure in Cape Town. And what we've seen subsequently is that our, most companies in South Africa are actually using both Ireland and Cape Town together. Typically, their low latency applications have been moved into Cape Town, where their more cost sensitive applications have actually been moved into Ireland because Cape Town is a bit more expensive than Ireland from a cost perspective. What we've also seen is, our customers using the one region as a DR region for the other. So if they are primarily running out of Cape Town, they use Ireland for DR. And if they are running in Ireland, they use Cape Town as a DR, for example. And so moving on, just a case study of how you can actually save money with CloudWatch. So this is a really good example of how Terraform adoption can actually save costs in an environment. So when you create a CloudWatch log group, so this is something that would, ingest logs from various AWS services. By default, these log groups don't expire the data that's ingested. So they retain data for a long period of time. And this is trivial when you start out on AWS, but as adoption grows, all of those logs can actually cost quite a lot of money. So what we can do is we can use the retention policy that is set when you create the resource, as well as specifying, for example, a KMS key if we wanted the logs to be encrypted. And by doing this and creating a module, this means whenever somebody creates a log group, automatically it has a retention policy of 30 days rather than the indefinite retention policy that is created as a standard. And this can actually result in fairly significant cost savings. So, in this example, we have a log group that has, a lot of data being ingested into it, but also historical data, which adds up to quite a large sum of money. what we've also seen is that when you actually, start implementing these retention policies, for example, by standardizing on the adoption of Terraform modules, we've actually seen a real world saving of between 25 to 80%. And in large environments across tens or hundreds of accounts, this can easily total over $50,000 per year. So, this example may seem quite trivial, but a lot of these configurations for provision capacity, like EOPS on EBS volumes, DynamoDB tables, amongst others, can have significant cost savings if defaults are enforced programmatically. And this is something that you can do with Terraform and Terraform modules. In this example as well, I would just like to illustrate the irony between the fact that, we have a Lambda that's, executing quite frequently. However, the logs for the Lambda is actually more expensive than the Lambda function itself. And by implementing that retention policy, we can actually reduce that quite significantly. Another example is orphaned resources, something that Lance also mentioned. So when you create infrastructure, and depending on how you create it using the AWS console, especially if you then go create secondary resources after you've created an instance and you shut that down, the other resources won't actually be terminated. So these things include load balancers, network interfaces, EBS volumes, config rules, etc., NAT gateways. And so once you've deleted your EC2 infrastructure, you would still have all of these resources running, which would actually, consume quite a bit of money. And again, if you have tens or hundreds of AWS accounts, the spend is definitely not trivial. One of the other things that we've seen from an operational perspective is that, when people start adopting a cloud environment, typically they have an ineffective operating model because they've taken their bad on-premise practices into the cloud environment, and you really need to change that if you want to use cloud successfully. So one of the ways that we can do that is by using infrastructure as code. So unfortunately, most organizations use ticketing systems to provision infrastructure, which is often done manually, and this can lead to configuration drift between environments, something that the adoption of Terraform can avoid. And something to consider is that, as developers start creating infrastructure, typically, they are quite bad at infrastructure, and IT pros, and these are the kind of legacy IT people, for the lack of a better term, are really bad at code. So you, as an organization, you need to make a real good movement in the organization to actually bring these two teams together so that devs can create secure infrastructure, and that the IT professionals can also have the input in doing that. The next thing we need to do is enabling self-service. So often there's a struggle between the central cloud team and the app teams with who can provision certain things, etc. And by having that module registry in the organization, you can actually get around some of that. And one of the other practical ways to do this is by re-looking at how you do change management. So in the past, you would have like a change approval board, and that would take weeks to get a change in. What you really need to do is actually use the tools available to developers to actually change how you do change management. So let's say you have a repository where you have things like IAM policies, etc., which is typically looked after by the cloud team. Instead of having a very long request process from application teams to the cloud team, what you can do is you can say, okay, well, let's have those repositories open to everybody, but only the cloud team can actually commit to the main branch. And we allow application teams to create feature branches from that main branch, and then they can then do a pull request to have that merged into the main branch again. And when this occurs, we can have engineering and security teams actually review the change. And when you do this consistently, it can have a drastic impact in the way that change management is done in the organization, and how the organization will scale in a large environment. one of the other things that we can do is, if you're using Terraform Cloud or Terraform Enterprise, you can actually set Terraform Enterprise to actually apply automatically when something is merged into the main branch, which can also speed up the operations as well. And one of the things that we really need to aim for is to really have lots of small changes over large, big changes in the organization. And when you do this, you'll really start to see an increase in both agility and innovation in the organization. And one of the questions that I typically get is, how do I actually practically monitor Terraform adoption in my organization? So we actually found this a neat way to do this. So hopefully everybody has CloudTrail enabled in their organization. If you are using something like Control Tower or a landing zone construct, that's all of those logs are typically being sent to a log archive or audit account. And what you can actually do is you can actually look at these CloudTrail logs, specifically the event name and the user agent inside of those logs, to see what's actually making changes in your infrastructure. And then you can use something like Athena inside of AWS to actually run a query on this bucket to actually see what tools people in your organization are actually using to create infrastructure. And it's a great practical way to actually see, how or track the adoption of Terraform in your organization. So in closing, I'll just, very quickly highlight what we've spoken about. I spoke about secure modules, how you can have modules with approved configuration. You can have repeatability, where you can easily move things from environment to another environment, how configurations with baseline configurations can really save money, as well as the operational benefit of Terraform. And with that, I'll say thank you very much and hand it back to Justin.
Thanks so much, Jared. Some really great examples there. A fantastic presentation. Thank you very much for that. So now we're going to hand over to Siva. Siva is one of the senior partner solutions architects at AWS. So Siva, over to you. Thanks.
Thank you, Justin. Share my screen. Hello, everyone. I'm Siva Sadhu. I'm a partner solutions architect focusing on software partners across EMEA region, and I'm super excited to be here with you today. Continuing on the theme of optimizing your cloud cost that Rans and Jared have spoken about, today I'm going to walk you through a framework for cloud financial management and describe how organizations with good cloud financial governance are able to unlock and accelerate the economic value promised by the cloud. On today's agenda is an introduction to how cloud has turned technology procurement and consumption on its head, and how that 180-degree motion necessitates a new model for financial governance that many organizations are evolving into today. Once we are on the same page with how cloud has changed things, we'll dive a little deeper into what cloud financial management is. And we'll finish today's session with a quick overview of how AWS can help your cloud's journey, organization's cloud journey, be a successful one. So where do we start? I'm going to skip the all about AWS piece, because I hope we all have a baseline level of understanding of what cloud is and what cloud offers our respective businesses in terms of potential for disruption and transformation. What I do want to share, however, is that when we look at companies and businesses using AWS, we often hear and in fact see cost savings as a primary driver for the decision to use cloud. But organizations that use AWS realize value above and beyond just TCO reduction. Organizations also realize value in staff productivity, which includes improvements to staff efficiency, operational resilience, which refers to improvements in quality of service and SLAs, and also business agility, which includes increased innovation and reduction in go-to-market time for new features and products. So instead of asking yourself whether cloud is right for you, I think a more important question is to ask yourself, what value you expect to realize across these 4 value areas as you plan your next digital transformation. Now, about digital transformation, today's business leaders are in a race to move quicker, innovate more, and remain competitive. While this transformation is often marked by technological advancements, its effects ripple across organizations and processes that impact both what we do and how and why we do it. From a finance and procurement organization perspective, the process for capital budgeting, capital request, approvals, procurement, and installing physical infrastructure is one that has been learned and standardized over decades. Engineering or IT teams are typically the requesters. Various finance teams act as approvers and procurers. Operations teams rack, stack, and hand off ready-to-use infrastructure. Approvals, procurement cycles, and operationalization activities slow down experimentation and innovation for technology teams who become blocked on long-pole dependencies they have no control over. This process, as well established as it is an antiquated model, and as we see in the next slide, requires adjustments in order to be successful in the cloud. With the adoption of cloud, infrastructure procurement and consumption is no longer beholden to a chain of dependencies. In the cloud model, technology and product teams are no longer just builders, but operators and owners of their products, who are responsible for most of the activities which are historically associated with finance and operations teams, including procurement and deployment. All it really takes to provision cloud resources is a user account and the right set of permissions. This is also what reduces IT and finance risk. And by that, I mean, teams are always just few UI clicks away or API calls away from terminating idle or unnecessary cloud resources. This is also what allows technology teams to innovate faster, the agility and the ability to spin up and then tear down their experiments. And while the variable nature of cloud consumption may impact predictability from a capital budgeting and forecasting perspective, cloud provides organizations with the ability to reduce the cost of over-provisioning, as well as reduce the opportunity cost associated with conservative under-provisioning. Now, all of this is a big transformation for organizations used to working in the old model. It is incumbent on us to think about the best way our customers can undergo this transformation successfully. A mental model that may help with the transition is that cloud is just another data center, but one that requires us to evolve off our existing financial governance capabilities. As I mentioned earlier, AWS offers on-demand provisioning that make it easy for anyone to spin up resources. What kind of guardrails are needed to ensure only those individuals or teams that need to spin up resources for the right reasons are able to do so? We just saw an example earlier. AWS offers 200 plus services, each with different resource types and different pricing models, from on-demand, commitment-based purchase options like savings plans and reserved instances, as well as easy-to-spot instances. While AWS's pricing model is transparent, navigating this pricing landscape can be complex even for advanced end users. Over-provisioned cloud infrastructure, especially production environments, are challenging to resize. Studies indicate that customers who migrate to AWS oftentimes bring their over-provisioned on-premises infrastructure with them, and those that are born in the cloud don't have the right mechanisms in place to resize their workloads. As I've already discussed, forecasting cost is made more complex given the elastic usage patterns associated with the dynamic workloads and pricing models that optimize on behalf of our customers. Will it still be possible to use pre-existing annual budget and forecasting processes to set expectations within your business regarding your cloud spend? Let's look at it. When resources are provisioned, their owners have often little value or little or no visibility into what their applications are costing in the cloud. Technology organizations are historically not attuned to cost, unlike other first-order non-functional requirements such as functional correctness, performance, security, and scalability. Finally, even after cloud waste is identified and addressed, the dynamic nature of cloud consumption means that there is a chance waste will still reoccur. With this said, can we quantify how using cloud as a traditional data center manifests in terms of the economic value creation and the promise of the cloud? With all of this said, do you find yourself using the old model for cloud consumption, the new model, or are you somewhere in between? We collectively refer to these groups or buckets of activities as cloud financial management. Cloud financial management, which I refer to as CFM from now on, enables finance, product, technology, and business organizations to manage and optimize and plan cost as they grow their usage and scale on AWS. The primary goal of CFM is to enable customers to achieve their business outcomes in the most cost-efficient manner and accelerate economic and business value creation while finding the right balance between agility and control. What we'll walk through next is a formal classification of all of the activities and capabilities into these 4 areas that create the building blocks for a framework that establishes a baseline level of cloud cost management understanding across our stakeholder groups. We will start with measurement and accountability, an area of the framework that focuses on capabilities that enable organizations to establish cost visibility and accountability for spend. These include leveraging accounts and tags to create a representation of how workloads and organizations are mapped to their AWS consumption. Building the right level of granularity for cost reporting and monitoring for stakeholders to enable real-time decision and avoid cloud budget overruns. Allocating cloud cost by implementing showbacks or chargebacks for cloud spend, including spend on commitment-based purchase options, shared services, and marketplace purchases to drive most cost-aware cloud consumption. And finally, measuring and reporting cloud efficiency and value KPIs, enabling organizations to measure the impact of cost optimizations and validate expected versus actual value creation. Cost optimization is the second area of the framework, and it focuses on capabilities that enable organizations to pay only for the resources they need. These include ensuring architectures, solutions, products, and deployments are designed and operated in the most cost-effective manner from the get-go to avoid incurring technical debt. Identifying and recouping spend associated with cloud waste for cloud resources that are already deployed. This happens when we incorrectly size resources or observe usage patterns different than what we expected them to be. We can take those savings and do something more productive with them. Using the best purchase option to drive down unit cost for our workloads, whether that's savings plans for EC2, Fargate, or Lambda, reserved instances for RDS, Elastic Cache, and other reservable services, or even EC2 Spot instances, which offer the deepest cost savings for fault-tolerant EC2 cloud workloads. And finally, reducing TCO of cloud whenever AWS innovates on your behalf by adopting new services, regions, features, solutions, or price reductions. We have looked at the example where customers have been adopting the new South Africa region after it was launched. Planning and forecasting, the third area of the framework, focuses on capabilities that enable customers to improve business predictability for current and new cloud workloads. These include evolving your current budgeting and forecasting processes to become more agile and dynamic to accommodate the more variable nature of the cloud consumption. It may even involve incorporating additional units of forecasting, moving away from trend-based forecasting to driver-based forecasting that leverages unit cost. Leveraging new methodologies to estimate the cost of workloads using AWS tools like Migration Evaluator, AWS Pricing Calculator, or just a plain old POC that is deployed to a test account, tagged, applied a load against, and measured. As we discussed earlier, a large part of the value customers realize when using cloud goes above and beyond just cost savings. As such, it's important to quantify expected value creation across staff productivity, operational resilience, and business agility to build a data-driven process while considering future workload migrations or even benchmarking value creation for existing cloud workloads. And finally, many customers live in a hybrid world because They're in the middle of a digital transformation accelerated by the cloud. To enable a holistic end-to-end view of your entire IT estate, it's important to integrate your cloud planning processes with those that you currently use for your on-premises IT. Cloud financial operations, our fourth and final area of the framework, focuses on capabilities that enable customers to evolve organizations, processes, automation and tools, and establish a self-sustaining, cost-aware culture of innovation. These include securing executive sponsorship to establish a CFM owner, or a team that will establish a standardized programmatic approach to cost management, which can drive real results and quantify cost and value outcomes compared to isolated and ad hoc efforts. Ensuring stakeholders across organizations have a common understanding of cloud cost. This can be done through reporting, education, gamification, celebrating efficiency wins, and establishing new working partnerships between finance and technology teams to enable more accurate budgeting and cloud spend monitoring. Building guardrails that help maintain or increase the agility provided by the cloud without having to worry about costly cloud mistakes, like unintentionally provisioning the beefiest resource types or accidentally leaving resources running over the holidays. And finally, evolving existing mechanisms, be it processes, automation, or tools, to help proliferate cost efficiency in a continuous manner across your cloud journey. To recap, we now have a framework that organizations can refer to not only create visibility and optimize cloud spend, but to make cloud spend more predictable for the business and stakeholders and build a long-term self-sustaining cost-aware culture supporting all waypoints in the cloud journey. Remember that AWS is here to help you get with CFM, and we can provide you support for each step of your journey through a number of service offerings, from building business cases that help quantify the benefits of moving to AWS, to demonstrations of native cost management tools and services, and also introductions to our APN partners like HashiCorp and Synthesis today, who spoke earlier about how automation, standardization, and governing infrastructure provisioning with HashiCorp Terraform can increase staff productivity, improve operational resilience, and business agility while minimizing cloud waste. I'd like to conclude by reminding you that helping our customers save money is part of our DNA. It is who we are as a company, and it's how we prioritize our business, working backwards from the customer. Thank you for your time.
Fantastic. Thank you, Siva. Great talk. Interesting framework there. I think we're going to go straight into the panel questions. I think Jared and Siva, if you're happy, we've got some questions there. But I have one I want to answer straight away, which was from, where is it now? Quickly looking at the questions here. From Shane about what is the best way to build an IAM policy for the user to be used by Terraform Cloud without trial and error. Now, unfortunately, there's no kind of real best way to do this from my perspective. And this is, I'm going to give mine first, and maybe Jared and Shiva, you can pitch in as well. For me, what is the best way? You have to, with most IAM tooling, you need to have a way to go through and test and make sure that you use your specialists to set up your infrastructure, IAM roles, and make sure that they are sufficient for your company's need, because every company is basically different. But what I would like to suggest is, once you've found this module or this policy permission set that you want, use something like HashiCorp's Vault tool to create a repeatable process for people to request access that can then be utilized in a way that's automated. So from their Terraform code, they can request access. The access is automatically then granted for the runtime at that permissions level. And then once the run is complete and everything is deployed, then the access can be revoked and that user no longer has access to the system. So just in time, if you remember my Zero Trust talk from, well, if you've seen, sorry, remember it's a year ago now, but it seems like yesterday. If you've seen my Zero Trust talk from previously, Zero Trust is key, access for only as long as you really need it. Jared, have you got any question or any input or extra to add? Or George?
Yeah, I think using Vault to do that is definitely, the right way to go. I think when you hook up Terraform Cloud, depending on what version of the product you're using, there's a few ways you can tackle that. So you can have what we like to call a jump account, where this is maybe like a central account. You have a user. Unfortunately, you do have to create that manually, and then you give those credentials to Terraform to use, and then you can cross account into the accounts that you need access to. I should also point out, actually, something we're very excited about. We've been building landing zones even before landing zones were actually a thing. And last week at reInvent, AWS announced the account factory for Terraform. And if you are using that, it makes it a lot easier to have Terraform Cloud provision resources into all of your sub accounts. So if you are looking at this from an organization perspective, definitely check out the account factory.
Awesome, thank you. Yeah, I mean, that was some great. I saw that announcement, and I think we've been working on it quite as a team, AWS and HashiCorp, for a while now to get that kind of just right. We've had feedback from customers and things like that. Shiva, your opinion on that?
Yeah, you mentioned good preventive mechanisms to for the IAM policy there, but I would also add to we have the service IAM Access Analyzer, which also provides a detective way to identify the third-party IAM principals that are active on your account and what kind of permissions they have. So there is no straight way to say the IAM policy requires all the permissions. We always recommend using the principle of least privilege. But it's to identify that fine balance about what is required for the Terraform to operate, and then use tools like Access Analyzer to see if you have overarching permissions, and then reduce the scope. Yeah,
I think as you eventually what we kind of go towards is you want to make sure that we spoke about governance. And I think governance is really key in these scenarios, preferably before people deploy environments, but also, if you have already deployed environments, it's a good way to go through and retrospectively check what permissions people have. There's quite a few other questions, but I've got, excuse me, for Jared. Sorry, I've got a frog in my throat. I should have had some water. Jared, kind of like more from a consumer user perspective from your customers, you mentioned in your talk about the willingness of people to change their culture and having to have a new way of thinking when doing this. I have my opinion because obviously we deal with customers as well, but I want to find out how have you found it very difficult to get customers to understand this like new way of doing things?
Yes, it's very difficult. And often, as I showed in that one slide with the operating model where there's a stall in the in their adoption, and really when that occurs, because we've actually seen it with multiple customers, you really need to go back to leadership and go, these are the problems you need to fix. You're not doing things in the cloud way. And one of the things we often see, customers are very attached to their on-premise way of doing things. So when they take all of that to them in cloud, things start going wrong very quickly because, the cloud, like the on-premise way of doing things, makes getting things done in the cloud very, very slow and very, very painful. And then you also have the other problem, which is a skills problem, in that the on-premise teams are not familiar with cloud, and that can also just add further implications into the culture. I think, it's something that I think a lot of people struggle with, and it's also not an immediate thing. It's always a maturity thing. You start out in one place, and then you constantly need to work on maturing it. There's always room for improvement.
Yeah, there's a saying, don't boil the ocean in one day, right? You can't.
Yeah.
Possible. Shiva, have you seen some similar challenges with your discussions with, it might not be in your direct line of business, but have you seen similar challenges with regards to people changing their mindsets about how this works or how cloud works in general?
A lot of the biggest challenges that we see for organizations using the cloud is not technology, but it's people and culture. I mean, the biggest difference between organizations that actually do it and having the most success in the cloud is when there is a cultural transformation as well as a transformation in the thought process about how things work on the cloud. It comes from various levels. First, with the senior leadership having aligned and truly committed to the transformation to the cloud, and when organizations adopt a top-down approach to the transformation, we've seen most success in that area. And we also see there is a significant knowledge gap. So having the organizations training their people on the cloud and bringing visibility into different tool sets, different kinds of partner solutions like HashiCorp Terraform, it makes people comfortable using this cloud, and it also helps them gain confidence in operating or building on the cloud. So it's definitely a shift in mindset that I see with customers. I mean, the technology is there, but it's the people who use the technology who need to shift that mindset.
Yeah, no, definitely. I think, having worked in, I won't mention company names now, but having worked with a lot of the big retailers in South Africa, hosting and being the engineer on their side, has definitely a change in mindset is needed. And when you have that executive buy-in to do this change, it helps going a long way. I mean, we have customers in our side here in Europe at the moment that we were talking with that have that very regulated way of doing things, and they're so their concern is kind of, how do we implement this? We have to do X, Y, and Z because of the regulations. For example, some EU regulation says they have to do something, and we have to do something. How do we get that done? And we've found out that you can. It's not around, for me, the way I see it is, it's not about how you're not offering them the solution. What it is you're not going to throw away all this process. It needs to be there. It's legally required, but you do it in a different way that speeds up your team. So your teams aren't doing 4 weeks worth of kind of clicking buttons. They're automating with their own scripts. Do you find something similar? Obviously, because you have a broader scope, perhaps. Do you find something similar, Siva, in your way of with the customers, like this really resistance because of the legal situation?
Oftentimes I see it's not customers don't have a complete understanding of the requirements or the compliance requirements. That's where we work with those customers to dive deep into those compliance requirements and help them understand how running workloads on the cloud, specifically on AWS, helps them to be more compliant and eases the compliance process as well. And automation and using automation tools or infrastructure as code will help them achieve that compliance faster and help their teams to move faster also. It also improves visibility into if their infrastructure is compliant, if their processes are compliant or not. So to answer your question, there is, I wouldn't say resistance, but lack of complete understanding. And that's where we work with customers to help them understand and peel different layers of the compliance, help them identify how running their workloads on the cloud is going to help them move faster and be better compliant with all the regulations.
Yeah, awesome. I mean, I think that's the same thing. It's the misunderstandings. Jared, I mean, I know South Africa's got some really strong sovereignty kind of rules with regards to data. How do you handle that kind of, hey, yes, you can put it there kind of scenario?
Yeah, we actually, because most of our customers are in the financial services sector, we really struggled with this. So, when we started in 2016, there was a lot of uncertainty about where data can be put. And in fact, one of the good things, and actually at the time, from a regulatory perspective, South Africa was a bit ahead of other countries. It was that our regulator, or the regulator for banks, the South African Reserve Bank, actually came out and said you can put data in the cloud. They actually created a cloud directive saying you can put the data in the cloud. Okay, it needs these protections. You can, outsource or offshore this data, including the secret customer data, which was, very significant. And it's like, if the banks can put their data in offshore, literally any other company, can do that. One of the things that still then happened was some people were more comfortable that it, was still in the country, and that's really the reason why the Cape Town region basically came online. Also, from a latency perspective, obviously, Ireland, there is some latency, if you need low latency applications. Yeah, it's been a very long conversation over many years. But I think today, definitely with all of the protections that AWS provides, plus the regulatory approach, I think we're in a good place.
Yeah, and I think as more and more time comes along, you're going to be getting a lot more companies that have this mindset of cloud first. If we can do it in cloud, we'll do it there, but we need to keep our systems of record on premise. And that's why you need this kind of local connectivity, right? I have another question here from Muzi. Muzi, yes, we do have cloud IBM. Sorry, the question was, do you support IBM Cloud Resource Provisioning? Yes, there's a provider for IBM Cloud. I've used it. It is very functional and works really well. So yeah, just go out there and read up on it. There's a deck. I'll actually copy it into, or I'll give it to Marianne or whoever can copy it into the channel, wherever it's supposed to be. I don't know. I'm just here speaking, but I did make sure that I have a link to it. One more question, I think, to the both of you. I think we can start with Jared answering first. Have you seen a significant improvement in customers' willingness to try and save their costs using cloud technologies as a solution? That's a very broad statement, so that's why I deliberately so.
Yeah, definitely 100%. In fact, one of the main reasons why people go to cloud is because of the cost savings and specifically the agility. One of the big benefits of using cloud technology is that if you want to go test something, you can easily spin up infrastructure and you only pay for the hours that you use, and you don't need to have this huge capex cost of going to buy servers and then doing the maintenance and putting it in a secure facility, etc. All of that's that heavy lifting is taken away from you. And I think a lot of people, they don't fully understand it. But I think once they start using it, then they start to understand, the benefits that it can add. So 100%, I would agree with that. I would just add, though, I think both the culture and the way that you manage your infrastructure is very important, because if you're going to take the on-premise stuff into cloud, you're probably going to not really realize the full benefits of cloud. I think that's quite important.
Yeah, 100% agree on that one. Shiva?
Yeah, as I've mentioned during my talk, cost savings is one of the primary drivers we see customers moving to the cloud. And we often have customers who use the well-architected framework to analyze and measure their workloads, and specifically the cost optimization pillar on the well-architected framework. Customers use that to identify how do they optimize their cost on the cloud, because the key design principles there is to implement the cloud financial management, as I've spoken a bit earlier, and where you adopt a consumption-based model for your cloud resources. And in the end, you measure the overall efficiency of the value creation that the cloud brings in, and also reduce cloud waste and stop spending money on undifferentiated heavy lifting. We also have tools that help our customers identify what the cost that they're spending in the cloud, cost and usage reports, and other tools that I can share a link. Customers use these to analyze their expenditure on the cloud, attribute those costs to different services, different teams, different departments. And with that visibility, they understand where to optimize that cost. So it's definitely a key motivator, a key driver for customers using their workloads on the cloud, and they use different set of tools that we provide.
No, thank you very, very much for that. I appreciate the insights on this. I mean, for me, the whole thing about saving costs is we want to be able to make that efficient journey. As you say, you know, you want to realize those savings. You want to make sure that those savings are real for the customers. And now, specifically in these tight times where we're living with the changes in how we work, we need to make sure that everything, every dollar, every rand, every cent we spend is going in the right direction, going to make that value more, or keep the value as good as possible. And I think using tools like Terraform and policy as code to limit and to maintain and to give those guidelines that people have, right? If you look at the way, automate everything so that you reduce those mistakes. You want to govern everything to make sure that you've given those guidelines. And you want to standardize everything because you want to make sure that everything is deployed and maintained in exactly the same way. So any outlier, any change is quickly identified as saying, that's not according to standard. There's potential cost losses there. Let's go and find out why they're doing it not according to standard, and let's get that sorted out. And I think those are the kind of three concepts that we can agree on, I suppose, hopefully, that you want to make sure that you capture in the core of this and the essence of this, right? No matter what you use to deploy as your cloud service, right? Cool.
Right, thanks, Lance. Guys, we're coming to the end of our allotted time here. So I just want to take the opportunity to thank all the attendees for joining. And thank you to Siva, Lance, and Jared for some fantastic presentations there. As we mentioned right in the beginning, this has been recorded and it will be shared with everybody that's attended. We'll also add on contact details. If there's anything you need to talk about HashiCorp related, please just reach out to me. My contact details will be in the follow-up email. But again, thanks everyone, and thanks to all of the presenters for a fantastic session today. Some super interesting questions and amazing stats and figures and insight on how we can look at reducing some of the cost through Terraform in public cloud. So yeah, with that, I'd like to wrap up everything and have a fantastic day, everyone. And thanks again for joining.